The third video in this series is going to look at other rational functions, graphing them, and specifically we're looking at a linear function being divided by another linear function. So if you look at this rational function over here, you can see something that resembles y equals mx plus b on the top. This also looks like mx plus b on the bottom. They're just using different letters. And so we begin by looking for our asymptotes with these two linear functions. Your vertical asymptote will come from the denominator. Again, the denominator cannot have a 0 in it, and so they give us this formula, which I don't like. I'll just explain it to you. But what they're saying is, if you took this denominator and set it equal to 0 and solved it for x, that would give you what x cannot be. And now I would divide by c, and this is where they're coming up with this formula right here. So it's not really a formula. What I recommend is that you just set the denominator equal to 0, and whatever value of x comes out is your vertical asymptote. The next one you kind of just have to memorize, and that is the horizontal asymptote. And the horizontal asymptote comes from dividing the leading coefficients of your numerator and your denominator. So here's your a on the numerator, and c is your denominator, and you just take those numbers and divide them, and that is your horizontal asymptote. So let's see what this looks like when we do it in real life. So looking at example 3 here, you can see that you have rational functions in this form where you have a linear function dividing another linear function, or being divided by another linear function. And here is the example. Y equals 2x plus 1, all divided by x minus 3. First job is to find your asymptotes. And so I'll start with the vertical asymptote. And if you just remember that it comes from the denominator, it's not such a big deal to find. Remember, it cannot equal 0, so we solve it for x to find out what number would have made it 0. So if x equaled 3, and we put it back into our equation, you can see that we would have ended up with 0, and that's not allowed. And so we just found our vertical asymptote, and I will draw that in the best I can. Alright, next job is to find your horizontal asymptote, and that comes from the leading coefficients. So those are right here. In my numerator, I have a 2, and in my denominator, there's a 1. Remember, they're the numbers before the letters. So if I took 2 and divided it by 1, you get a 2, and that is your horizontal asymptote. So I just found my two asymptotes. Your second job then is to plot points to the left and the right of your vertical asymptote. So the green line is my vertical asymptote. I'm going to pick a couple points to the right and a couple points to the left. And again, you can pick whatever you want, as long as it's not the actual asymptote. And I am going to pick 5 and 7 to the right, and to the left I will pick 2 and 0. And you substitute those points into the equation above, and watch out for your order of operations and make sure you are inputting them correctly into your calculator. I'm going to go ahead and round. There, I'll use a fraction because it's easier, but those are my coordinate pairs. So we plot them at 5 and 5.5, 7 and about 3.8, just estimating. Not so easy on an iPad. And then we have 2 and a negative 5, and 0 and a negative 1/3. And then, knowing how your ends of your branches behave, we just sketch it in. And you graphed another hyperbola. Let's do some guided practice, but now that I'm looking at it, I think we ought to go over domain and range a little bit. Remember, the domain is your x values, and that is when you take your eyeballs and you sweep them from left to right. And so if I'm looking left to right, there is only one number that your x value cannot be, and that is right here. That's supposed to be on 3. It is your vertical asymptote at 3. So for your domain, it can be all real numbers. You could use your symbol if you want, all real numbers, except x cannot be 3. However you want to write that again. Just get the information across to me. For range, I'm going to have fun here because they updated my program, and I'm going to use a lightsaber. So for your range, you are sweeping your lightsaber, oh that's not very fun, up and down and seeing what y values come out, and you can see your red hyperbolas are represented here, but suddenly at this 2 you do not have any values there at 2, and so that is your range. It would be all real numbers except y can't be 2. And again, however you want to say that. We'll get more practice as always with domain and range. Here we have some guided practice for you. So I'm for sure doing 5 and 6. You can do 4. I'll get the asymptotes in there for you. But remember, your first job is to find your vertical asymptote that comes from the denominator, and then you find your horizontal asymptote, which is the division of your leading coefficients. So pause the video and come back and check your answers. And here's what those hyperbolas ended up looking like. Number 5 was kind of tough because the numbers were so small, the ones I picked anyway. Number 6 was pretty straightforward, and then number 4 I just did the vertical and horizontal asymptote, and we'll leave it to you to draw the hyperbolas, although they are somewhere in here, in case you didn't know. Alright, I have that one way too far away, by the way. I should fix that, but I'm not going to. Alright, if you have any questions, you know where to find me, and that was the 3rd video in this series on graphing simple rational functions. The next section is graphing general rational functions, and in that video I'll just give you general rules that will apply to graphing any rational functions except for the transformation ones. Those you have to know on their own. Thanks for watching.